Everyone. Welcome to another episode. In this episode, I thought of taking a different approach. So, there is a 30-day LeetCode challenge that has started from today. So, what is going to happen is every day LeetCode is going to release a new algorithm question for next 30 days, and you will be given 24 hours to solve one question. So I thought it will be a good thing in this lockdown situation to keep your mind challenging and active. So let's get on with the question. So the question states, given a non-empty array of integers, every element appears twice except for one. Find that single one. So your algorithm should have linear runtime complexity. It also asks us if we can implement it without using extra memory. Okay, let's understand this problem by looking at the input. So in first case, the input is 2 comma 1 comma 1. So obviously 1 is the integer that appears only once. In the second example, it's 4 comma 1 comma 2 comma 1 comma 2. So 4 is the output. Let's try to look through diagrams, what all approaches we can try, and then we'll code it together. So let's consider the input 4 comma 1 comma 2 comma 1 comma 2. So one way would be I can just iterate through this array using a for loop, right? So for I equal to 0, I'll consider this as array A. So I0, I till this size is n, let's say less than n, I plus plus. I keep a map of key will be my array element, which is A comma I and then count. So I keep a map. So in C++ we can use unordered map because unordered map is a data structure that allows you to use key and value pair. So after this for loop, basically our count will be 4 is 1, count of 1 is 2, count of 2 is 2. So we are going to iterate over this map once more and then find the element which exists only once. So this is time complexity of this problem will be O of n, but because we are using this extra memory of map, the time complexity, space complexity will also be O of n. But the question states, can you implement it using it without using extra memory? So what other approach we can try here? So the hint is hidden inside the question where it says that every element appears twice except for one. So here I'm going to introduce a calculation using bit manipulation, um, which will obviously won't involve any space complexity. So let's understand how the bit manipulation works. If you guys know XOR, you must have studied it in your school time. So how the XOR works basically, so if we draw the table, so 0 comma 0, if we do a XOR of 0 0, it will be 1, XOR of 0 1, sorry, XOR of 0 0 will be 0, XOR of 0 of 1 is 1, XOR of 1 0 is 1, and XOR of 1 comma 1 is 0, right? So you see, when the bits are alternate, we get a XOR bit as 1. So what we can infer from this question, so every element appears twice except 1. So what will happen if I XOR 2 with itself? Let's write the way I always do bit manipulation is I always write this decimal values in bit in binary, how it will look. So 1 2 will be 1 0. Now if I do XOR with 2, because I know how the XOR works, this will give me 0. So basically XOR value of 2 2 is going to be 0. What will happen when I do XOR of this with 1? I'll get 0 0. If I do XOR with 0 1, I'll get 1. So basically if my array is 2 comma 2 comma 1, if I do a XOR on all this whole array, the only value that stays remaining will be the one which exists only once. Because for example, let's say when our array was 4 comma 1 comma 2 comma 1 comma 2. So let's look at this step by step to understand it more properly. Let me write it here: 4 comma 1 comma 2 comma 1 comma 2. So 4 is written as 1 0 0 in binary. I'll take XOR of it with 0 1. I'll get 1 0 1. Next I'll take XOR with 2, 1 0 1, and then 1 0. I'll get XOR of 1 1. Obviously this will be 0 1. So 1 1 1. Then I XOR it with 0 1. I get 0 1 1. Now I take this XOR with 2. What do I get? 0 0 1. What is this in decimal? This is 4. So our theory is correct that when we take XOR of all this whole array, the only element that left existing will be the one that exists once. So let's code it now, because and it doesn't use any extra memory also, right? So overall time complexity is O of n, and overall space complexity will be O of 1, because we are not using any auxiliary space. So I can just take, let's say 0, awesome. So we see the code was itself just 3 lines of code. This operator is XOR operators, and we saw that the proof that taking XOR on the whole array will give us the element that exists only once. Hope you guys enjoyed this video. I'm gonna make a video of all the problems that I'm gonna solve in this challenge. I'll ask you guys also to participate in this, because it's a good way to keep your mind active and keep practicing the algorithms. If you guys like this video, please subscribe to the channel and don't forget to like the video. Thank you.